Hi, today we'll create a Tower of Hanoi using a stack implementation. Tower of Hanoi is a puzzle game where you need to move all the rings from the first pole to the third pole. However, you cannot stack a ring on top of the smaller ring. Alright, let's begin. In this project, we'll break it down into three steps. First is the ring, second is the pole, and finally the game logic itself, the Tower of Hanoi. For the ring, we need a mesh to represent the ring. To create it, we need a torus. You can create the modeling section. After you open it, you can choose a torus and then put it inside the map wherever you want and then just accept. Alright, we already have our torus, and from here we're gonna use a simulate physics, so we can just put inside our pool later. So in here, if we try to put it upside, as you can see, the gravity didn't work. So we need to checklist the simulate physics, which require the simple collision. We can open from our static mesh right there, and then we gonna add our collision. From the collision tab, we use an auto convex and then apply it. Okay, after you apply it, you already notice there is a line that represents as the collision. So if you go back into the map, and we will try to simulate the physics, go to the properties and then checklist the simulate physics. After we already simulate the physics, don't forget to save, and then we'll try to run the program again. Alright, as you can see, the gravity already worked and our ring already falling down. Now for the next step, we'll remove our ring at the map and we'll try to create the blueprint, so we could adjust and modify our ring using the code. So we will create a new folder using as we call it as blueprint, and we will put all code inside this folder. And for our ring, we will make an actor. We choose actor, and then we will call it as blueprint ring, just like that. Okay, after you open the blueprint folder, we'll add our static mesh, and then choose our mesh which we already create, the torus. Compile it, and also don't forget to apply the simulate physics. Okay, perfect. Now we'll try to put our mesh, our blueprint inside the map. So we're gonna go to back to map, open the content drawer, and then just drag and drop, put it inside our map. After that, save it and run the program. So as you can see, it's already falling down also. So we already complete our objective for creating the blueprint. Now we will try to modify it using the code. First of all, we're gonna make a new variable and call it as a size, which using a data type of integer. Okay, now from here, we're gonna use a construction script to modify our mesh. Alright, so we drag the static mesh from there, and we will change the scale based on our variable, the size. So we're gonna use set relative scale 3D, connect the line, and then you can choose the right click and split the stroke pin. We could change the XYZ from there. Drag and drop the size, and then from here we're gonna multiply it, and then we're gonna change it using the float. You can change it by using a right click right there, and then put 0.25, and then we're gonna add some initial size. You can add it and then put 1 right there. Connect to X and Y. For the Z, we're gonna use a constant one because we didn't want to change the height. Alright, compile it, and then you could see it in the viewport. So for example, if we go back to the size and change its default value, you will notice it will become bigger. Okay, nice. Then we're gonna compile it. We're gonna use instant editable and expose on spawn for later for our project. So when we use instant editable, we could change the value directly inside the map. For example, if we just put the 4 right there, it will come directly a fact from our object. Now we want to change the color of ring, and we're gonna make it a separate color that represent its the size. So right here we're gonna create the material. We call this M color. Then if you open those files, you're gonna notice it looks like this. We're gonna make a new parameter, right click at the base color and promote it into the parameter. No need to change the value or the name, just apply it for now and then save. Alright, because we want to make the material will be changed using the blueprint or using the code, we will create a material instance. So back to content drawer, right click at the material that you already created before and then create material instance. For the name, we're gonna use mi color. Okay, and then open it. Now, if you look at here, if you open the global vector parameter value, we could change our color. Don't forget to check the box, and then we could change the color directly for the material instance. Let's set it as pink for now. Okay, after we create our material instance, we're gonna set it into our blueprint. So for now, we're gonna go back to our blueprint, click on our static mesh, and then change its material. We're gonna use the material instance color. Alright, and then we're gonna go back to the construction script, and then after we set the relative scale, we're gonna create the material instance first. So from the static mesh, we're gonna call create dynamic material instance, and then from there we're gonna choose our source material, which is our mi color. Now we already got our material. We could change the parameter that we already set before. So we're gonna use set vector parameter value, and then we're gonna need to put the parameter name based on the global vector parameter. So in here, because we use the base color, we're gonna change it into the base color. Alright, compile it. And then after this, we could change the value from those pin. So from there, we're gonna use an array, but so we could call the array, we could use around a little bit, call it a get from the array first, and then we call make an array. In here, we're gonna make around 5 types. So you just need to add it until the fourth index, and then we set it the color one by one. For the 0, we're gonna use a red first, and then after that, we're gonna use blue, then green, yellow, and finally purple. Alright, now for the index itself, we're gonna use from the size itself. So it will be based on index 0 to 4, and to ensure that we didn't exceed those array, we're gonna use clamp from there. We're gonna set is the for the maximum, we will likely to get the length from the array that we already created before, and then subtract it by 1, so it will become the last index. Alright, so from the return value, set it into the index from the get for the variable from the array. Then after that, as you can see, in the viewport, the color already changed based on our size. So let's change it again. Alright, fantastic. Let's set it as 1 for now. Okay, go to map, and then as you can see, it already changed. We're gonna duplicate several for the testing. Well, let's say we're gonna make another 2 with the different sizes. Okay, set it to 1. One more time, we're gonna set it as a size for 2. Okay, don't forget to save it and then run the program. Okay, after we finish creating our rings, right now we're gonna go to another step. We will create the pole. So for now, we're gonna experiment it first using a basic cylinder. So from there, you could choose a shape and choose cylinder. Then we're gonna make it a little bit thin and put it directly on the center for each ring, so it could fall down right into the inside of the ring. Okay, we're gonna make it thin. Let's say for the scale for x and y, we're gonna set as 0.1 and make it a little bit taller. We will change the value inside the scale of z. Okay, now we already got our pole and try to put it directly into the center. You can adjust it manually, put it perfectly at the center point, and then if you already think it's already in the perfect location, you could save it and then try to put the ring upside, and then just run the program. Okay, I think that is already like what I expected. So for now, we're gonna remove all those things and we're gonna create our new blueprint for the pool where we're gonna implement our stack. So inside the folder blueprint, we're gonna create an actor right there, and then for that, we're gonna create a BB stack tower, which is become our memory for the stack consists of the blueprint of ring and also the base mesh itself. So for the base, we're gonna use a cube, just make it smaller like a plane, but there's still a little bit height right there. So you can see as a three-dimensional shape, and then add another cylinder just like before when we create it at the map. Change the scale it also, set this as 0 0.1, 0.1, and then we could set this as 5. Alright, perhaps a little bit taller, so we could just reduce it. Maybe 0.3 will be quite enough, I believe. Yeah, we just need to use the scale of 3 for the Z. Compile it, and then just like before, we could put in our map, just drag and drop our blueprint. Alright, nice. We could just try using another blueprint ring. Okay, if it already is at the center location, we could just save it and then run the program. Okay, smoothly insert into the stack tower. Now we're gonna complete our blueprint for the stack tower. Let's go back to our blueprint, and then for now we're gonna add another component called arrow as the initial location for the spawn the blueprint ring. So we could set that our stack tower is also gonna be a spawner for the blueprint ring. No need to worry about the rotation because we're gonna need only use their location only. Now we will add a variable for the stack itself. Sorry, wrong place. Okay, add the variable, call it as a stack, which is will become an array that consists of our blueprint ring. You see object reference because we're gonna store the object, not the class. Then compile it. Save. Alright, for another variable, we're gonna use a counter. Use integer. Use it as a single, not an array. And for another one is called as the capacity. The same data type is the integer. Okay, now we're gonna add another function. So the function we're gonna make is to accommodate our stack. So first of all is push to add another value or object into our stack. You can use the stack and just directly add, create another new parameter, and then we will increase our capacity. You can use an increment or just type it plus plus right there. Alright, nice. So for another function, we're gonna create it is a pop. So pop is basically to remove the variable or the value that we already store in the stack, but in here we only take the top value from the stack, and then we're gonna return it as a return type from there. First of all, we're gonna need to check is our stack is empty or not. If it's already empty, we just will return the value as the empty value, but keep it into the return variable also, so it will help us to know is when we call a pop is literally our stack is empty or not. We call it as a ring, and don't forget to change the data type as a blueprint ring. Alright, for the second case is the default case when if the stack is not empty. So in here we're gonna get the last index from the array, because when we add a new value we just use a push or add like that. So in here we're gonna get the last index from the array using the variable of capacity. Just reduce it by 1 and then you will get the value of the last position of the index. We're gonna save it into the local variable. So in here the local variable will be stored just only in that function, not into the global value. And then we're gonna set it as a current ring. After we already save it, we could safely remove the value inside our array, inside our stack. So if we already remove the stack, we still have that object, at least the reference itself, so we could just return it later. Just call remove, pass it the same reference, and then after we already remove that, we could decrease our capacity. Just use minus minus or perhaps type as a decrement integer. And then don't forget to return the value for the function and set it as our current ring. Okay, nice. So we're gonna compile it. And then after that, we're gonna create another function. It's called top, or we could also call it as a peak, which is this function is for us to see what is the top value inside our stack. We could just copy it from the pop, but in here we do not want to remove the object from the array. In here we just literally return the variable after we get the data from the array. So you could just delete several nodes from there and then connect it after false right into the false one and then connect it to the get. Okay, perfect. So we already make all the functions that for us to accommodate communicate inside the state, and then when we want to know get a value or add another value, we could use this one. After we create all the functions that we already need, we will create the spawner. So from here, when we want to spawn our rings, we're gonna use the begin play. For the easy part, we could use a for loop actually. So in here we're gonna try it. So we're gonna use the counter, set it as instance editable and expose on spawn. We're gonna get it, put it near the begin play event, and then let's say for now we will set it as a 5. We will want to spawn around 5 rings. Call for loop. So with for loop we could just set our first value and last index. But in here we just need to subtract it by 1 because we just want to set it 0 to 4. After that, inside our loop body, we just need to spawn our baby ring. So don't forget to set the blueprint ring right inside there. For the size, we could change the size when we create our object because we already set it using expose on spawn. That's why we need to use expose on spawn if you want to change those variable directly when you want to create it. It's quite similar to the constructor in several programming languages. Okay, for the spawn form, we're gonna use our arrow, but in here because we just want to use the location, just need to get word location and then connect it directly to our spawn transform. Okay, nice. Now we will use push function to add our ring inside our stack. We don't want to use the add laterally because we already got our function, just use it. Now, moment of truth, when we run our program, as you can see, when it crumble into one location and become a big pool like that. So in here, because the for loop, it will be run instantly right there. So there's quite an alternative, but the best case if you want to change it, we're gonna make our manual looping using a branch. We will keep our code for spawn and add to the array. In here, we're gonna change it using a branch. Quite similar to before, we will use the variable of counter as an indicator or the index inside the loop. In here, we're gonna check if the counter is still bigger than 1, then put it directly into the boolean inside the branch. And after that, after the branch, for the node of true, we're gonna reduce our counter. So we can just get our counter and call it using decrement integer or minus minus. Connect it one by one, and then don't forget to set it the counter inside our spawner. And then in here we could add a delay to ensure giving some times for them to spawn it one by one. And after that delay, we're gonna connect it after the complete back into our branch before. If you want to add another node like that, you can use a double click inside the line. Now we already have our spawn logic, and it will run when if our counter is more than 0, and also if our we need to spawn our rings. So in here, after reduce, and then they will spawn in, push into inside our stack. Okay, compile, and then we go back to our map. Okay, as you can see, there's some delay time, and it's not already crumble like before. Oh yeah, I forgot there's still one ring. We need to delete it, and then try to run it again. Okay, perhaps we need to increase our delay. So if you see it, there's some it's quite quick, and our ring cannot adapt to the gravity directly. Oh yeah, we also need to switch when the ring is spawned, because currently the smaller one will be spawned first, then it will be continued by the larger. So in here, we'll try to switch it up. So how do we do it? So in here, we're gonna subtract it first based on, because currently we only have a 5. So we're gonna use a 5 minus by counter. One more thing, because we use the first index is 0, we're gonna use a 4. Okay, and then don't forget to increase our delay. Set it to 0.5. Okay, our spawner has already worked, and it's quite similar to Tower of Hanoi. We just need to create another pool or another tower. Now for the last part, we'll create the game logic itself, the Tower of Hanoi. So we will remove our spawner first, and then we will create another blueprint inside the folder of blueprint for our gameplay. So in here, we're going to use a pawn. So why we want to use a pawn? Because we want to use an input directly into the blueprint. So we're going to use bb Hanoi Kim. Okay, in here we're gonna add our stack tower. You can use child actor. We're gonna make it as a tree. You could assign the blueprint right there and then call it a stack tower. Alright, so save it and then we could set the value inside the template and also set the default. In here we're gonna set it for the counter. We're gonna set it as a 5, copy it 2 times, and then for the remaining tower we're gonna set it as a 0, 0 counter and 0 capacity. For the capacity variable will be changed based on our function from the push one. Okay, it's already quite similar to our image before. Set 0 and 0. So we could also rename our component so it's more easier if we know which component that we need to set. Is it stack 1, stack 2 or stack 3? Compile and then add a camera. We just need to put it right in the front of those three and try to ensure the position is quite fit and all of the tower will be inside the camera. Okay, I think it's already centered enough. We just need to rotate it a little bit. So let's say set to 90. Oh, minus 90. Okay, compile it, save, and then we just need to put it inside our map because this project is quite an experimental. So in here, so when we run it, we want to see directly. We can use auto process player, set it to player 0, save it and run. Okay, it's already working and it's already spawning also. Nice. Okay, now we will add another arrow right in the front of the camera where we will know for the selected ring, we're gonna put it right there, right in the front of the camera. Okay, I think it's already fine. Compile it, and then now we're gonna do some code. Okay, in here we're gonna use the input key. So you could select key. We're gonna use 1, 2, and 3. So 1 for the stack 1, 2 is for stack 2, and 3 for the stack 3. You can change it directly inside the properties right on the right side of the screen. We're gonna set it one by one. Okay, now because it's exactly the same code but different stack, we're gonna create a new event. So add event, you custom event, and then you could change it whatever you want. In here we're gonna add a number, an integer, which stack that we use. Choose it as an integer, and then we could call it directly when it's pressed. We want to set it, and for the easier access, we just set it using 0, 1, and 2. So for the stack, we could just put inside an array rather than we use a branch for one by one. Okay, just like that. Now we're gonna continue to code, make a new variable, and then we're gonna check it is already being processed or not using a boolean. Second one is the current ring. Are we already selected our ring before using the BB ring? And the third one is current stack. So basically we choose our stack first. If we didn't choose any ring, we're gonna take the ring first. Okay, don't forget to change our variable type. Inside our custom function, first of all, we need to check it's already being processed or not, because we didn't want to call it multiple times in the same time. So we need to check it. Is it being processed or not? It's still in the being process. We do not want to make another process, so we're gonna continue in the false. Then in here, we're gonna compile the stack into the one place. We're gonna use a select using the select button and select integer. And then as you can see, it's quite similar to the array. In here, you can just put it directly using its option. You can add another pin, one by one. Okay, nice. And then from there, inside our return value, we need to get our child actor first. So we could access that instance. In here, we need to cast it into BB stack tower, so we could access all the codes inside it. Then the return value of the cache will set it into our variable that we already created before, the current stack. If it's already selected, we need to set the process into true, so it indicates that it's already being processed, so you cannot initiate another call function. Now, for the second part, we need to check is we already have our current ring or not. You can use is it valid or not, just like that. So in here, we're gonna use the first case is when we didn't have our current ring. So we'll work on if it's not valid. So what we need to do in here, we need to get our stack and then just call pop. Call it as a pop, connect into is not valid. And then as you can see, it will return the variable of ring right there. So we will get the value of the top and remove the top also. Inside the ring, we need to check it first, just like before. Is it valid or not? If it's already valid, then we could believe that that's the stack we choose is having the ring and will get it. But if it's not valid, then we could assume that process already done. So we just need to disable all the process. Now, if we already set it as a valid, we just need to set our current ring based on the variable that we already popped. Yep, just like that. We only need to set the value, and then after we already have the value, we just need to move it from the tower, stack tower right there, and then put it right in the front of camera. To do that, we need to disable our simulate physics. We can create another custom function inside here, and let's call it as set physics. With the given a parameter of boolean, just literally call physics or true, just like that. And then we call the static mesh and set simulate physics, connect it directly inside of the parameter. Okay, nice. So we already have our custom function. So in here we just need to disable it. Set physics just like that. Set it as a false because we don't want the gravity effect when we choose our ring. Now let's go back to the stack tower and we'll create another function to get the location from our spawner. Why we need to do that? Well, basically just for the animation so it will be looks much better. And also when we want to insert it back again, we just need to put it right there and then it will fall down just like when it spawned. So we just need to return the location of the arrow at the return node and connect it directly. Don't forget to compile it and then we're gonna back to our gameplay. So inside our pawn. So inside our current ring, we could get our actor location and it will become our initial location. In here, we will use the timeline and also using a looping or linear interpolation to make a smooth animation translation like that. So in here, we could just use a timeline. Let's say we could rename it as first move. We're gonna play it from the start, double click it to open the timeline. We could change the length as the 1, so it's a track length. You just need to set it one by one, rename it the channel as alpha, right click to create a new point, and we're gonna make it 0, 0, 0 and 1 and 1. 0 time and 0 value, it will increase by a time to value of 1 in 1 second. We can use some kind of smoothness right there. So you just need to right click and choose what you need to do in there. As you can see, it will become a smooth curve right there. Let's go back and compile it. We're gonna back to infant graph to create our translation. So in here, we'll need put inside the update. It's quite similar to the loop because it will be run over the time, but in this case, we just call our ring and then call it as set actor location. Set actor location connect it to the update. For the location itself, we're gonna use linear interpolation based on the alpha that we already get. It will be increased over time from 0 to 1. We're gonna use the initial location from the A point. For the B point, we will use the position of spawn location from the stack. We could get spawn location just from the function we already called. Okay, as you can see, it will be an action node like that, but we want to make it quite easier like get actor location. In here, you could just select the pure one, compile it, and when you go back to the event, it will change. That's quite similar to get actor location. Alright, it's already connect both of them. Connect into the set actor location. save it, and then we are done for the first move. For the second move, we want to from the initial spawn location, it will go directly right in the front of our camera, which is the arrow that already we created before. Connect it to complete, and you can copy it like before. Don't forget to create the variable of initial location, quite similar to the before. You can copy also the linear interpolation, connect it one by one, connect the alpha for our initial location, and also for the B, we're gonna use the arrow. Get the world location, connect it to the B, and set the initial location just right before when we want to go to the timeline. Okay, nice. So we can complete it. And after already finished, we just need to set the process as a false. Just need to compile it, save, and rerun the program. Okay, let's try to use the input. I think it's not. Oh yeah, we need to make the static mesh as the root. Okay, after you change it as a root, when you click the keyboard button, it will change move just like that. Okay, the first step is already finished. We just need to move to another process when we already have the current ring and we want to put it inside another tower, another stack. So we could use go to the another position is valid. It's quite similar to when you want to choose it, but in here we just need to check it first. From your selected stack, you get the current stack, call the function of top, and then from there, you the thing that you need to check is it valid or not. That's the first thing that you need to check. If it's not valid, just put it directly. If it's not, we need to check its size. So here we get size, and then we will compare it to our current ring. And then connect into the branch to check the condition. So basically, if the top is bigger than the incoming current ring, we could push it directly inside the stack tower. But if it's not, do not do anything, just set the process back to the false. Okay, nice. But if all the condition is already fulfilled, we could call push function from the current stack, call push, connect it from is not valid and through from the branch. Inside it will be the current ring. Now it's already inside the new stack. So basically the current ring that you already choose before, we could move it to another stack using this code. Now, after we already stored the data into the new stack, we just need to create another timeline to move from the initial location to the new stack. Just right in the spawn location. After that, we're gonna call the set simulate physics. You can copy it from the previous code for the linear interpolation and set actor location. Set into the update, connect into the alpha. For the initial location, don't forget to set it first, just like when you decide to collect the ring first from the initial ring as initial stack. Then finally, we could set the finish as the process back into the false. After you set the current ring, the physics of the current ring as true. So you will enable the physics first. Also, you need to empty the variable of current ring, so we could choose another new ring if you want to move it. Okay, everything is already goes as planned. We'll try to see if it's already like what we expected. We'll try to run it. Now we're gonna choose our ring and then put it into another. Okay, as you can see, the physics start too early, so we need to give I think a little bit delay will be sufficient. Just right after the finish. After the finish, before we start the physics, let's say we give a little bit delay around 0.2, just like the default value of delay. Okay, quite good, I think. Let's compile it and rerun the program. Choose one. Now let's put into the center. Okay, let's go directly. There's quite a physics problem right there. How about we try to reduce the mass so it's quite a floating, a little bit bumpy. You could change the mass inside the ring. Just select the mass right there. Rather, default value is 100. We're gonna change it into 1. Don't forget to compile it. Then when you rerun the program, you can choose the ring first and then choose another new stack. And yeah, it's already working. And it's not like what we think it will be broken. Let's see, we choose another ring, put inside it, and when we want to choose another stack, it cannot. We need to put it back. Alright, that's all for tutorial of Tower of Hanoi. Thank you for watching and see you in the next video.